8.1 exponential growth. First thing we need to do is go through some definitions. First of all, an exponential function, and I want to abbreviate function as fn. An exponential function, so it's in function notation, f of x equals b to the x. Exponential means that there's going to be an exponent in the function. This b belongs to, and it's just this backwards kind of e looking thing, the reals, meaning it can be anything as long as it's not a 1, because 1 to anything is always going to be 1, therefore it wouldn't change the exponential part of it. So b can be anything, positive, negative, fractions, radicals, anything, as long as it is not 1. Alright, we're going to look at, in our calculator, what these functions do. So we're going to look at the function 2 to the x in the calculator. So in your calculator, under y equals, clear out anything that happens to be there. Make sure all the plots are off, none of those are highlighted. And we're going to type in 2 and then exponential. So for me, that's the caret key. If you have the newer models, it's going to raise it up to an actual exponent. X. So 2 to the x. Alright, and graph it. Again, if you had something in your calculator, you probably need to reset your calculator. We're going to reset the calculator by going to zoom, and then 6 is standard, so zoom 6. And there we go. Alright. So with this exponential function, we want to check out the end behavior of our graph. The end behavior is what is happening at the end of my graph. So the way we look at that is that we're going to say as x approaches positive infinity, so as my x's get larger, what's happening to the function? And the function would be the y values. So as my x's get larger, what is happening to my y values? The function, because f of x means y, the y values are approaching positive infinity as well. Alright, so let's go the other way. As x values approach negative infinity. So over here, here are my x values. As they get to negative infinity, what is happening to my y values? Where are they going? Now you might need to zoom in so you can actually see what is happening here. I'm just going to use the zoom box so we can see what is occurring as my x's keep getting more and more negative. Notice that the graph keeps getting closer and closer to the x-axis. So as my x's approach negative infinity, my y values, so my function, my f of x, is approaching 0. So what this means, the line y is 0, which happens to be the x-axis, is an asymptote. So what is an asymptote? An asymptote is a line the graph approaches but never touches. All right, if we were to keep blowing up our picture and keep getting it bigger and bigger and bigger and bigger, we would see that this graph here actually gets closer and closer and closer and closer to the x-axis, but it actually never ends up touching it, no matter how far out that we go. And that's the whole definition of an asymptote. And when we graph an asymptote, like if I were to graph this picture, I would make the x-axis a dashed line. So we would graph an asymptote as a dashed line. And there can be vertical asymptotes, horizontal asymptotes, and we'll get into how to decipher those. But for right now, an asymptote is denoted with a dashed line. I do want you to refer to your book, page 465. There's a brown box that talks about the properties. Go through the activities. What happens when you change your equation, and what happens when you change some other pieces of it? What happens to it? But you need to look at page 465, and you need to know those properties and understand them. I'm going to quickly go through them without the book available, but you have your book that you can turn to and refer to. Anytime we have our equation, we're going to have our y-intercept is going to be the a, and that comes from the equation a times b to the x. This a is going to determine what the y-intercept is. So if I come back up here to this 2x, notice it is there. I can have a 1 in front of that, so it's 1 times the 2x. We just wouldn't write it, but it is still there. And that's why when you look at the graphed picture of this, it does go through the y-intercept at the point of 1. The domain of every exponential, how far left and right does the picture go? Well, the picture is going to go forever to negative infinity, forever positive infinity, and it doesn't matter how we change that picture, the domain will always be all reals. The range is based on the a. If our a is positive, which means it's greater than 0, it's going to be all the y's greater than 0. All the reals greater than 0. If my a is less than 0, or my a is negative, it's going to be all the reals, or all the y values, less than 0. In our exponential functions, we have a growth function. And on a growth function, the equation y equals a b to the x. A is positive, meaning it's greater than 0. And b is greater than 1. The picture itself will increase as you read it from left to right. So it looks something like this, like the one that we did. It increased from left to right. All right. We will also have decay functions, but we will talk about them in a couple of days. Right now, we're just going to have positive growth functions. With these growth functions, we can shift them. We can move our exponential picture. And we're going to shift the function the same way we shift everything. All shifts are done the same. It does not matter if it's a parabola, if it's a line, if it's a circle, if it's anything that we ever talk about when it comes to graphing. We were going to shift them the same way. And that way is with h's and k's. And we saw this with our parabolas, where our h moves to the left, right, opposite sign, and our k moved up, down with the same sign. Well, it has the exact same properties in exponential functions as well. So what we're going to do here is we're going to come up with ways to do this, but you're going to use a t-table. So the first thing we need to know is that k is our asymptote. So kind of come back up here to our original f of x equals 2 to the x. Notice there's no k out here plus 0. That's why 0 was our asymptote. So if we now put plus something out to the side, that is our new asymptote. The way that you are going to graph these is you are going to use a 5-point t-table, and you're going to draw just the original parent function 8bx. No h's, no k's, just the original parent function. Then we're going to shift the hk of each point. Keeping in mind that h is our x, that's our left, right, that's our x component, and k is our up, down, or the y component. And h is always the opposite sign, and k is the same sign. Alright, so anytime you're asked to draw these, you're going to do it in a 5-point t-table, and you're going to then shift. So you're going to have kind of two different tables within one. So let's take a look at what that is going to be like. So these are, you will have a non-calculator quiz, and this would be part of a non-calculator quiz, being able to do these by hand. So let's go y equals 2/3 times 2 to the x. Whenever you make your t-table, you are going to start with your x values, -2, -1, 0, 1, and 2. Those are always going to be the x values that you start with. Always. Your default with them. Then we'll shift things, move things left to right. Okay, so here, in this case, I don't have an h, I don't have a k. So all I'm doing is just plugging in my points. I won't have any shifting. So I'm going to get 2/3 times 2 to the -2. Now, last chapter before Christmas break, we talked about how that works. That becomes 2/3, negative crosses the line, changes the sign, and 2 squared is 4. So altogether, when we reduce this, we get 1/6. Then you're going to do 2/3, 2 to the -1. When you reduce it, multiply it out, we get 1/3. Put in 0. That becomes anything to the 0 is 1. And then put in a +1. When I put in a +1, it becomes 4/3. And when I put in +2, it becomes 8/3. So when I graph this, I'm going to graph it -2 to +2. -2, 1/6, 1/3, 0 is going to be 2/3. 1 is going to be 1 and 1/3. And then 8/3 is going to be 2 and 2/3. And there's our graph. Arrows are on it. Our axes have arrows and labels. Yes, these are points that will be counted on a quiz. So please don't lose silly points because you didn't label and you didn't put arrows. And then the last thing we need is an asymptote. And the asymptote is going to be 0, our k out here, plus k. So we're going to go back and put a dashed line at 0. There's k is our asymptote. This is our y-intercept, so we did cross at 2/3. We had no shifting, no h's, no k's, but k is our asymptote, so 0 is our asymptote. All right. And again with this, the domain is all reals, and the range is all reals greater than 0. Next one, y equals -2 times 2 to the x. We're going to make our t-table. We're going to use the x values, -2, -1, 0, 1, and 2. Going to plug those values in. So we're going to get -2 times 2 to the -2, which is 2 times 1/4, which is -1/2. -2 times 2 to the -1. So -2 times 1/2 is -1. -2 times 2 to the 0. So -2 times 1 is -2. -2 times 1, 2 to the 1. So we get -4. And then -2 times 2 to the +2 gives us -8. Right. When I go to graph this, I only need to go my x, y values to -2 to +2. My y values need to go to -8. So I'm going to make my graph accordingly. Arrows, labels. If your number is below 15, you will go by ones and use your graph paper. Each line will be 1. You do not get to use another scale unless your number is above or way above 15. So -2 is -1/2. -1 is -1. 0, -2. 1, -4. 2, -8. Connect our dots with arrows. The asymptote is the k. There is no k. So the asymptote, a dashed line, is the x-axis. Again, domain is all reals. The range now is all the reals, but it's less than 0. Alright, so let's look at some shifting. So this is a normal above the x, this is a normal below the x-axis. So let's look at some shifting. So y equals 2, 3 times x minus 2, plus 1. Alright, when we do these, we first do a times b to the x. So that means I'm going to ignore the 2 and ignore the 1. The only thing I'm looking at is 2 times 3 to the x. So I'm doing 2 times 3 to the x. And I'm going to do -2, -1, 0, 1, and 2. When I plug in a -2, if you need to do the side work, feel free. So this is 2 1/9. The -1 will give me 2/3, 0 will give me a 2, 1 gives me a 6, and the 2 gives me an 18. Alright, so that's just doing the parent function, a, b, x. We ignore the h and k. Now we're going to second shift h and k. So the h, -2, is actually add 2, because remember it's always opposite, 2 to the right. And plus 1 is 1 up, so we're going to add 1. So this is actually going to become negative 2 plus 2 is 0. That's going to become 1, 2, 3, and 4. The shifting on this is going to be 1 2/9, 1 2/3, 3, 7, and 19. Now when I make my picture, I need to have my picture x values go 0 to 4. And I need to have my y values go 0 to 19. 19's over 15, so I can use a different scale, maybe 2s. 12, 14, 16, 18, 20. And then plot them accordingly. So 0, 1 2/9. 0, 1 2/9. 1, 1 2/3. 2 is going to be 3. 3 is going to be 7. And 4 is going to be 19. Connect the dots with arrows. The asymptote is 1 though. So I need to go back here and make sure my asymptote is at 1, which is below all of my points. So when I'm connecting my points, I need to make sure that they're above my asymptote. My domain is all reals, and my range are all y values greater than 1, the asymptote. Okay, so that is day 1 of 8.1.